And without further ado, I'd like to welcome Mohammed Munir and Bryce Daniels to the stage.
One thing we didn't plan for at all was who's going to sit where. So, of course, that's a good way to start. So we're going to talk about securing AI. So, Mohammed, maybe you want to introduce yourself real quick?
For sure. Hi, everyone. My name is Mohammed Munir. Day job, I work on the incident response team at Mandiant. Part of the work that I'm doing with the organization, I'm leading our Securing AI Solutions service. The section that I'm going to speak to is the learnings that we've had over the last year of helping organizations prepare to adopt AI in a secure manner, but also help organizations that have already adopted AI to try and understand what the security implications are, what the risks are, and basically how to mitigate those.
Yeah, so my name is Bryce Daniels. I lead our offensive security team for our Northeast region, and I'm going to be kind of walking through a little bit about what AI is, and then talking a little bit about some of our penetration testing assessments that we've done for AI applications, and sort of what's perhaps the art of the possible about what some attackers might be able to do, and just things to keep in mind as you're trying to make perhaps like a risk-based decision process to, how you want to implement and secure the AI infrastructure that your companies are going to use. So with that, I'm going to dive into it. So as I said, we want to define what it means to sort of be AI. And I think one of the interesting things is that, well, perhaps as I was listening to one of the sessions earlier, and Dave Wong said most boards know what AI means. That's an acronym they actually do understand. But I think what's kind of interesting is that AI means a lot of different things to a lot of different people. There were some business analysts who used to say that if something was actually working in production, then it was machine learning. AI was whatever was in the future. Feels a little bit like perhaps we're finally into the future at this point now that we have large language models. But the more recent buzzword has been around, what does it mean to be agentic? What makes an AI agentic? And that kind of gets to this idea of some type of an application that can take steps essentially independently by observing the world, and use some set of tools that have been provided to it by the organization. So, is everything, however, that we are going to be talking about an agentic AI? And I think that's one of the areas where it becomes kind of important to realize that the answer is actually kind of no. Not every single LLM or generative AI is in fact going to be agentic. And that comes to play because the attack surface, which is what defines the risk profile, is going to come from some of the answers that you might make to these questions. Some of them are going to be agentic. Some of them are going to be information retrieval. Some of them are just going to be a chatbot that maybe has nothing specifically to do with your organization. So how you are able to answer the question about these different applications is, I think, going to define some of that risk. And you could think about this. I don't know if you want to cover this. This was your slide originally, but what I was trying to say, though, is that concept of like a vanilla chatbot, that's like the lowest potential risk that maybe is there. You have an idea of like people are going to throw content to this, and then it's going to come back with it. So you just need to manage that type of risk. If there's some type of retrieval, though, that by sort of classifying it that way, that is going to be, there is a type of data, whether it's part of the training data set or maybe it was part of retrieval augmented generation, where something specific about the user is brought into the into the session, that increases some amount of risk because there's information that the chatbot has that perhaps the user is not supposed to be able to ask the chatbot about. And then it kind of grows out from there, and the amount of data that the bot is able to do.
I'll just make a quick comment here. If you take a look at the two different examples on the screen here, vanilla chatbot and information retrieval, consider this even in different stages of complexity of the use case and how the attack surface for each one is going to be different. So if you're looking at something that's a vanilla chatbot, let's just say you're using an LLM, either an API call going out to the LLM or directly just using the LLM. At the end of the day, you're not configuring anything, you're not modifying anything. You might have configuration on the controls or the platform for the LLM, but you're not really doing anything to modify the behavior of the LLM. So the attack surface for that is going to be different. The risk profile for that will be different. The second part, the information retrieval component, now you're adding that RAG component to it. That might be something that you're putting in there. That might be something that you are configuring in order to modify the behavior for the agent. And now the attack surface is different, because what if the RAG is modified? What if it's missing? What if it's misconfigured? And Bryce is going to go into a little bit more details on how the bad side of that looks like when it goes sideways. It goes really sideways. But I definitely want you to start considering this from the perspective of different use cases, different profiles for these applications have a completely different attack surface. So we want to be cognizant of that.
So as we think about how we interact with the model, the sort of security implications in many cases are going to come from different ways in which you have an interaction. So you have a prompt. Well, does the application depend on the source of the prompt? In some cases, a prompt may be may include previous parts of a history. And so there might be elements of a system prompt or content that is provided by the agent itself, in addition to that's specified by the user. And so, as you look at these various different sort of ways in which an attacker or hopefully just your users are interacting with the various different LLMs and agents, this is going to sort of start to give you an idea of what are the type of risks or the ways in which this can potentially go sideways a little bit. One of the ones that I don't have here specifically listed on the slide, but has obviously come up in the last several months, is the MCP server, or the way in which an agent can talk to another agent. And there's a different type of interaction model that might potentially be there, and a level of trust that is assumed because it's coming from what maybe is supposed to be a trusted label. So definitely different ways in which that security can be implied. One of the last sort of concepts of security that certainly comes to mind as someone working with penetration testers all the time, is that an AI application is still at its heart an application. And the risks that are posed by it being an application do not go away just because the main way of interacting with this is through a chatbot. And so if, as you're trying to manage the risk, you do have to manage the risk from the perspective of it as an application as itself. So I think the last thing from an introductory standpoint that I kind of wanted to say was, as I was putting this together with Mohammed and we were kind of talking through these things, and one of the things that started to stick out to me is almost how we've wanted to build functionality and capability into our applications that's really flexible. And it kind of started to remind me of when Microsoft was adding Visual Basic scripting capabilities into much of Office, sort of in like the early 2000s. And so you had somewhat foundationally the, I love you virus. And it just really kind of came to my mind because, I don't think they anticipated the level of risk that they created by enabling scripted access to the address book and the ability to send emails automatically. And so I think as we look at the security of agents, we have to think about the fact that an attacker may come in and do some things that we just don't necessarily anticipate. And that's part of what it's going to be to manage that risk. So kind of diving specifically into how we have attacked AI applications in the last year or so. Hopefully everybody was here in the keynote. And you heard one of our consultants make a comment about having a 200-month loan. This is actually the chatbot giving us that 200-month loan. We did this as part of a partnership with BCG, and so I can kind of share that a little bit more directly with you. But this is kind of where in a way, because of this proof of concept application was not designed with a lot of security controls, that it had inherent risks in it. And so it's a good demonstration of sort of, in a way, maybe the worst case scenario. What would happen from a legal perspective if an attacker said, yeah, but your chatbot gave me this 200-month 0% APR loan, and now are you on the hook for that? But, anyway, diving into some more of the specific examples, I just wanted to sort of set the stage of like, what do you do first if you're doing an AI application pen test? And funnily enough, one of the first things you might do for reconnaissance is to just literally ask the agent, what do you do? What can you do? But don't summarize it. Give me all the full details. And in fact, sometimes we've used this to actually get a huge amount of detail about what the agent is capable of doing, and it's provided us with quite a bit of steps that we could take in the future. Now, a lot of times as we're going through the setup of the application, we've learned a little bit about what it's capable of doing. Now we start to see the different parts of the attack surface. I highlighted this particular detail about calendar permissions because it was something that was actually fixed by Google in one of its implementations. So figured I could talk a little bit about that. We were not part of that per se, but it is something that was an issue that they had to address. And that's the fact that an attacker, if they have a different way of interacting with the agent, they may be able to cause the agent to do something that you just don't really anticipate potentially being possible. So in some cases, there may also be, other types of rules that maybe an attacker can create within, an application that get automatically triggered, and then they run in the context of the attacked user. And that can enable the agent to say, share all interesting things by emailing such and such address. And these types of attacks, can execute in the background. And again, kind of going back to that, I love you virus kind of concept, you want the agent to be powerful, but by adding that power, you've created, potential risk for this. So you somehow have to almost infer the actual objective of the user. What are they trying to do so that you can manage the appropriate capability and then the risk that might be imposed by it here. But the only way to do this is just like with that 200-month loan. You've got to do some testing to see, what might an attacker, maybe do. So I'm going to transitioning a little bit, just as an example that I thought was kind of a cool one, just referencing Trail of Bits. They had done some research showing that not only does the calendar invites or, some other automation rules, if the attacker is able to control certain types of information, as the LLM is processing that data. So in this case, they used an image file that would get compressed before it was processed by the LLM. And they figured out that compression would create visual artifacts in the background of an image. And they were able to control the original image such that as it was compressed, it created text that the model would read. And that would create a potential input to the LLM and cause some potential attacks to happen there. So it just kind of builds on what I was saying a moment ago with yet another kind of example of how you almost have to assume that extra prompts may end up getting injected, and they may be assumed to be part of the user directed prompt, and how is the agent going to differentiate between those two? So as you're implementing these things, and this is not quite directly related to the idea of a controlling of a prompt, but there can be this idea of a amount of oversharing of sorts. So if you were in here just before this session, Gibran was talking about how attackers can use tools to scan file shares. And let's just say that my team finds a lot of data on the file shares of the places where we're doing a red team assessment. And one of the things, though, that a lot of these agents are being set up to do is they're being set up to run through SharePoint, through OneDrive, through the various different file shares at the organizations where those are implemented. And the agents basically become a shortcut to find the data, that is most useful to those users. So just the idea of being able to open up your agent and just say, how much money does my manager get paid? It's just the agent, if they have access to the data because it was shared with them inadvertently from some HR file share, the user doesn't have to go find it. It's just going to be there. The attacker may be able to leverage that to, gain information about configuration files or other credentials that might be shared within that, with those systems. So there's lots of different ways in which data oversharing can be, a potential risk that, you want to manage and track. So as the user is interacting with, or the attacker is interacting with the various different models, some other ways in which they can cause issues is how, I alluded to it a little bit before with oftentimes the prompt contains message history from a variety of different interactions that the user has had with a given agent. And so if there's a weakness in the application, the attacker may actually be able to provide history that doesn't really exist. They can actually write, in the case of what we did in this example, we were able to create structured data that had the entirety of a conversation that didn't actually exist, but we could tell the agent that, the agent had told us X, and, then we proceeded to respond with Y. Well, in this case, we also could say, add our own system messages. And if you're not familiar with the way in which prompts work, as I alluded to earlier, a system prompt is a more powerful prompt. It's something that tells the agent something it's supposed to do. So you can really attack an agent and potentially jailbreak the agent or do something similar in a way that you wouldn't have otherwise. So definitely a lot of power that can come from being able to provide that message history. So just one other quick example of something that might come in as you're interacting with that is just the ability to say to the model, load this, please tell me about a thing, tell me, about this person, and it just so happens that you essentially end the query practically with what is traditionally called SQL injection, SQL injection, and that can be a way in which you can pull some extra data from the database and cause some potential issues. Most of the time, this would be dealt with by the application security team, but because this is coming from an agent, it may have some extra capability that wasn't properly considered by the security team. So the last example that I want to give before turning this over to Mohammed to run through sort of ways to think about this is, I've presented a whole bunch of things about what are alerts, or what are things that are bad. And in theory, you could simply structure a whole bunch of data, and you could, look at the text and say, well, anything that contains these words, maybe you're going to produce an alert. And so you at least know that an attacker perhaps is attempting to access your systems. One of the problems, though, is what happens if you're, because this is a natural language interaction, what happens if your application starts to cause an easy way for alerts to be generated? So to give you kind of a more material example than my slight ramblings, we tested, again, with BCG as part of our partnership, we ended up testing a spa application. And this application, could help you to schedule the spa services, et cetera. And so they had implemented detections, actually leveraging another LLM to identify things that were suspicious. However, it was a spa application, or a spa scheduler, and so if you wanted to schedule a massage, every single time that phrase or even just the word massage appeared, the alert was fired for inappropriate workplace behavior. And so there were just tons that we flooded the alert system with inappropriate workplace behavior. And it just essentially would turn that, turn that alerting system, detection system, into effectively a useless kind of way to run things. So you really almost have to be careful as you're designing and trying to go through these things in, hopefully, a smart way, but trying to make sure that there is not alert fatigue, that these are manageable, alerts that you're going to create that actually are more meaningful to the systems.
Thank you. All right, securing AI, easier said than done. This last year has been really interesting for us as we have engaged with organizations at different stages in their AI adoption journey. Security teams at their best day are slammed. There's always a resource constraint. There's going to be some kind of a capability gap. There's going to be a visibility gap. There's going to be a governance gap. There's going to be some kind of a misconfiguration that the teams are struggling with. It might be endemic in the organization. And now on top of that, we have agentic solutions coming in to make their life even more interesting. So it's always interesting, number one, talking to those organizations, helping them figure out how to ideate on securing AI. But it's always a challenge as well, because those teams are burned out. Those teams are already struggling with, I don't want to call it legacy IT, but just IT in general. They're struggling with securing the environment. Application security is not always a given. And again, like I said, now we're dealing with AI on top of that. So first off, I want to identify the organizations at different stages. I want you to think about this from the perspective of three different buckets, if you will. There will be consumers. These are organizations that might have acquired an enterprise license for an LLM, and that's all they're using it for. They might have gotten it for all their employees, they might have gotten it for a subset of employees, but they're just using that as a helper or just as something that the teams have been provided. There are other organizations that might be in the second bucket, which is the integrators. This is where organizations are using LLMs and they're using capabilities like RAG to add a configuration, a customization to that LLM. At the end of the day, you're still using a third-party LLM, might be an API-based solution, and you're adding those system prompts, you're adding those guardrails, the RAG components that are providing customization. In this case, the LLM might also be accessing your own data. So it's no longer making up responses based on its trained data, it's now retrieving information from the data you've given it access to. So as I stated earlier, now you're dealing with a slightly different risk profile. And you're also dealing with an organization at a different stage in their maturity of adoption of AI. Now again, these aren't also mutually exclusive. You can be in buckets number 1, 2, and 3. You can be in buckets 1 and 2. You can be in buckets 1 and 3. And unfortunately, you can also be in buckets 3, or the bucket number 3, which is the trainers. These are organizations that are training models, third-party models, open source models. They are using training for automation, orchestration. Those agents are taking action. And the reason why I said unfortunately is not that you shouldn't be doing this, but rather perhaps security considerations have not been taken into account. So everyone can do AI, not everyone should do AI. We need to understand that. There are certain approaches that you need to take. If your baseline security posture is not up to snuff, you're already struggling with your security posture, there will be implications once you adopt these applications. The best approach is the proactive approach, but that's also the path least taken, where we want to prepare ahead of time. Some organizations have definitely taken that approach, but they've had an interesting journey as well. I shared this with a few gentlemen that I spoke to outside at the booth. I'll share it here as well. We were working with an organization a couple of years ago, actually, 2023, and the board of directors had basically stated, we don't understand the risks of LLM at the moment. We don't understand how this changes our security posture. So they came out with a decree to the security team to say, disable this at the network level. So block all access to mainstream LLM domains, and they did it. What was interesting at that point was they didn't realize that vendors might have already started using LLM under the hood. So they may have taken a decision for you, for your organization that might be opposed to your risk profile. In that case, that is exactly what happened. One of their security appliances was using an API for an LLM platform to enrich the alerts. So when they put in the block, that feature stopped working. And when they put in a ticket to that vendor, the vendor asked, did you guys do a block recently? Yep, we did. Well, we were using that to enrich the alerts. That led to an insight for us, which is vendor management is key again. You need to ensure that when there are updates, upgrades to your existing platforms, you are aware of what the feature updates are. Are they introducing net new capabilities around LLMs? What is your organization's risk appetite? Are there specific type of LLMs that are preferred over others? And what is the meaning of them getting access to your data or visibility that they have to your environment, to the data? How is that being used? So from a proactive perspective, those are areas that we want to touch on when we're talking about governance. When we're talking about governance, we want to set those guardrails. And that is something that we found organizations were lacking early on. Many organizations adopted these capabilities. They didn't really take into account what the governance implications were. This was also facilitated as a result of not having a lot of regional regulatory requirements. So there weren't really a lot of requirements, and there still really aren't, around what you need to do from a security perspective. But we have requirements around privacy, we have requirements around data security, so those still apply here. But that's where we started working on helping organizations understand, number one, what is old is new again. The same old risks are still applying, but then what are the nuanced risks that we have to address here when we're talking about governance? Shadow AI is a major problem for a lot of organizations. Shadow AI has creeped up for organizations where either they were keeping developers from ideating and developing because, again, they didn't really have a path forward, so they decided to block. But people will do things. They will start testing things. We ran into a situation where somebody was running Olama on a local, basically a M2 MacBook Pro, using corporate data to train a model just to test it out. They didn't have any malintent. They weren't trying to steal the data. They were just trying to train the data. But the problem is, somebody walks out with that laptop, they've got a trained model on corporate data. Plus, they also have the data on a external hard drive, which is a whole separate issue. But the whole idea is, well, how do you define shadow AI? How do you detect shadow AI in the organization? How do you prevent it? And user awareness is key. That's part of governance. And when we're talking about user awareness, it has to be multidimensional. You have to address not just the end users that are just using LLMs, you also have to address the developers, the people that are actually working on developing these solutions in your organization. You also have to consider the people that are deploying these applications. Most of our clients are acquiring applications and deploying them, acquiring them from third parties. Not everyone has the capability to develop these types of applications in-house. The proactive approach, again, we need to be proactive from the perspective of identifying risks. We need to understand what our own risk appetites are, respective to each organization. And we need to also understand from a security aspect, what do we need to do in order to mitigate the risks that are being identified? There's also an element of unknown unknowns. We need to discover those quickly so that we can start mitigating those. Detection and response is something that we've had, number one, a lot of traction on, but for good reason. Every single time I've worked with a detection and response team in context of AI, I've gotten back a lot of, basically they've expressed a lot of frustration. We don't know what the components are, so how are we supposed to ask for logs? They've given us a lot of logs, we don't know what to look for in those logs. So there's definitely a bit of a gap between the developers and the teams that are responsible for creating detections and responding to them. There's also a gap in understanding what the response procedures look like for these types of applications. If I was to tell you, what is your incident response plan for an agentic application? Does anything come into anyone's mind? So if I was to ask you, how do you validate model integrity? Or how do you recover an agent? How do you sever data that is being used for training purposes? And in the event that you recover a model, you're going back to the good old days of, well, we just recovered this VM from a week ago. Any modifications made in that week is lost, but at least we can go back to a week. Now consider this from a model perspective. If you have to recover a model, you're going back in time. Have you just lost training for that model? How do you address that? There are other elements here as well. When models are being offboarded, what does that process look like? You have new versions of agents coming out. What does that look like? Bryce mentioned A2A. This is going to be another interesting challenge, agent to agent. Organizations are considering exposing their internal agents to talk to third-party agents. So that means an internal agent can talk to a vendor agent. Well, what if an attacker comes in and figures out a way to add their own agent to that chain? Now you've got an agent in the middle. So some interesting challenges here for sure, but the good thing is asking the questions, because once we ask the questions, we can start planning on addressing them. And of course, we're adding to the queue of questions that the security teams have to answer. The final element is always going to be key, user awareness. User awareness has to happen. Something was mentioned earlier on as well around ensuring that leadership, there's a demystification of these applications are for leadership, but also for end users. They need to understand exactly what the capabilities are for these applications and what the implications are in the event that they're not using best practices. And what really are best practices at this point. But that's where we need to consider privacy, data leakage. Good old muscle memory kicks in here. We give those types of directions to our end users in general when they're on the internet. We just need to extend that to the AI component as well. Our approach to securing the AI pipeline, if you will, we take a look at data security, we take a look at model security, application security, and infrastructure. Data is going to be a given. Whether this is a simple use case where you're using an LLM, all of us are familiar with business email compromise. Somebody gets phished, their account gets compromised, somebody takes control of their email account, they're able to get access to the address book, they're able to get access to any documents that are sitting in the inbox. Perhaps that credential gets them access to other sources like OneDrive, SharePoint. They'll also get access, if you have SSO, to whatever LLM solution you have in-house. What can go wrong there? If you don't have history disabled, then somebody can basically go in there and perform reconnaissance. If they're using that platform as part of their day-to-day task, well, if they're using it for code development, that history might be there. If they're using it for document summarization, that history might be there. If you're uploading documents for whatever purpose, you're getting a summary back, You're getting it to assess, analyze, that might be in there. So now you need to consider it from the perspective of how are we securing these platforms? You've also got the other end of it, where we're talking about retrieval augmentation. You might give access to these agents to your own data. So what does that look like? We need to consider security around that. And data governance and data security is definitely something that, even take AI out of the equation, it's always a challenge for organizations. But now with AI coming into the mix, we've got a complexity happening here. It's not just data getting access or agents getting access to the data, it's also the metadata being generated by these agents. What are you doing with those? There's an interesting use case. This is right now more so it's relevant for financial institutions, the insurance industry, healthcare as well, where you have to consider the decisions that agents are taking, explainability. So when we're talking about metadata, that's part of it. Are you configuring the logs to be able to capture that, and how are you storing that? Model security, again, if you're hosting the model in-house, integrity for the model, understanding the access controls to access the model, what do those look like? What are your backups for the model? What does that process look like? You need to answer those questions. Application security, at the end of the day, this basically is an application. It's got a certain feature related to it, but we're basically dealing with application. So application security applies here across the board. Infrastructure is something that we had an aha moment early 2023, which was a lot of people were asking, what is AI and what does security for AI look like? The aha moment myself and a colleague had was, it's going to be hosted on the same infrastructure, so that is probably going to be a large part of the equation. So if I can compromise the infrastructure, is it possible that I can disrupt the AI application? Or can I backdoor the AI application? Or can I compromise the pipeline somehow? So if I compromise your Git repo, is it possible that I can compromise your AI application that way? So when we're talking about infrastructure controls, I'm also including into it supply chain controls. Those different elements are going to be key here. But we cannot rule out infrastructure. One of the examples that Bryce gave on the work that we did with BCG, the very first compromise that we did for that application, there was an exposed API. We were supposed to target the application, targeting it using LLMs, but the red teamers saw that API, they just basically walked right past all their controls. They were able to get access to the data on the back end. And the only reason was I think it was a misconfiguration. So infrastructure controls for AI is key. Basic security hygiene. I stated before, everyone can do AI, but not everyone should. Take into account your basic security hygiene. If you already have identity and access management control issues, if you already have visibility gaps, role-based access controls are a thing at your organization, as in a bad thing. Vulnerability management is something that the organization is struggling with. Consider how each one of those impacts the applications that you're going to adopt, the agentic applications that you're going to deploy. We did an assessment for an organization, and one of their primary services that they were going to be providing to customers was an AI app. And what was interesting was we identified a lot of silos in their AI pipeline, but the vulnerability management, when we asked them what their approach was, they basically said best efforts. And we paused and we asked them, well, what's your vulnerability management look like for the rest of the org, like holistically? And they repeated the same thing, well, best efforts. So if you're struggling on the infrastructure side, you're very likely going to struggle in the AI pipeline. Either figure out a way in which maybe a third party is providing you that service or assurance, but at the end of the day, your own environment might be a path for an attacker to take to compromise the AI pipeline. Again, infrastructure compromise cannot be rolled out. Identity and access management is going to be, again, something that is critical already, but becomes more critical when you have agents in the environment. Agents are basically non-human agents in the environment. I think in the keynote early in the morning, they'd mentioned that it's an insider, in a manner of speaking. Depends on who's using it and how. So if I can convince the agent to take malicious action, it will. So this is where we need to consider identity and access management. We're hearing a lot about MCP servers. They're intended to make it easier for you to be able to access the data, the different technology platforms that you have in your environment. If I bring in a malicious agent into your environment and I'm able to steal the token identity for an agent in your own environment, create a clone out of it, a malicious clone, and be able to access the MCP servers in your environment, then my malicious agent can now use your tools. So now I am basically living off the land, in a manner of speaking. So that again is where we need to consider what are our current identity and access management processes, add that AI component to it. And data governance, I've already talked about this, so in the interest of time, I'm going to go past this quickly, but if you are already struggling with data governance, understanding where the crown jewel data assets are, what they are, who has access to them, why do they have access to them, you're going to struggle with data being given access to agents. All right, some of the governance gaps that we're running into. Usage of third-party LLMs by employees. I actually ran into an interesting situation where the client gave me this term. This is not my term, but it gave me sleepless nights. They basically said, we've implemented bring your own AI. And for obvious reasons, right? That registers. So we asked them, well, do you realize you've just got a blind spot now where people are using this, that might be using it with corporate data. You have no idea how they're using it, the volume of usage. There's no transparency element. So how are you going to address that? And their whole context was, well, we're a forward-thinking organization. Fair enough, but you've also just opened up a huge risk for the organization. And then the example I gave you where your vendors might enable this capability within the appliances. Whether you are developing AI solutions internally, using them internally, or whether you're exposing them externally, you need to make sure that there are certain risks that have been identified and mitigated. We've heard comments along the lines of, well, this particular agent is only going to be internal, so the risk profile is going to be lower. But through the red teams, we know for a fact initial compromise is not a problem. So if that happens, then somebody might be able to target these agents, and they have. Our red team has, where they've been able to social engineer agents to divulge data. So don't use that approach to say internal, external risk profile is different. My recommendation, and again, this is my own opinion on this, apply the same kind of context for security for both those use cases. Acquiring solutions from third parties, this is where you might be getting a solution developed by a third party or acquiring something off the shelf. You might not know what the components are. You might not have the bill of materials for that particular application, for that use case. So you want to make sure you understand exactly what the components are. Like I said, vulnerability management is going to be a thing. Supply chain compromise will be a huge thing. In fact, in the last month, we've seen at least a couple of instances where supply chain compromises resulted in potential compromise for agentic solutions. The data being used for training purposes, you want to ensure that there is clarity on what data the agents have been given access to. We've seen situations where an HR agent had access to the CI/CD pipeline and the code in the CI/CD pipeline, which made no sense. And by social engineering that particular agent, it was able to divulge IP, it was able to divulge the code, and it also gave keys to the Git repo. So you want to make sure that there's no over-provisioning. You want to make sure the privileges are as required. So role-based access controls applies to agents. I'm going to quickly move to the last bullet there, making accommodations for future regional regulatory changes. This, again, is a little bit of a moving landscape right now, where we're not really provided concrete requirements just yet from government agencies or even from industry. It's still a lot of echoing of the same privacy, ensuring ethical considerations are being taken into account. So old muscle memory applies here, but you want to make sure that the approach that you're taking is something that allows you to be future-proofed. The approach that we've taken, we are aligning with NIST AI RMF, ISO 42001, and Google Secure AI Framework. That allows us to establish a baseline. When we're helping organizations, we're helping them align to those, in addition to any other regional requirements. So for example, organizations that need to adhere to it, GDPR applies. Components of that applies to the AI applications too. So we take that into account. This is one of the main messages I want to leave you with. Security is lagging behind. Unfortunately, it's happened.
We need to try and address this as quickly as possible. We need to make sure that awareness for the security teams when it comes to AI applications is current. They need to understand attack frameworks just like red teamers do. And there's really good data out there now. OWASP top 10 for LLMs and for agents is out there now. MITRE Atlas is out there now. We published our own Gaia top 10. There are a lot of different frameworks out there. The key is for them to understand exactly what those frameworks are and how to leverage them, how to use them. What applies to the red team applies to the blue team as well. It's only understanding what the vectors are, how they apply, and from there, they take their separate paths where the security teams need to understand how do we detect and how do we prevent. And finally, I want to leave you with this particular slide on the screen, if I can get to it. 10 tips for your AI program. If you haven't started, please review. If you have started, review it anyway. Introspection is never a bad thing. But it basically is meant to give you 10 tips on how to get started, how to get your AI program going from a governance perspective, the kind of controls and approaches that you need to take. All right, I'll leave that on the screen. The next slide is a thank you slide, so thank you all very much.